Welcome everyone. So our first speaker is Dr. Mengmeng Gu. Dr. Gu is a professor ornamental extension and extension specialist in Department of Horticultural Science at Texas A&M AgriLife Extension Service in College Station, Texas. She got her PhD in plant sciences slash horticulture from the University of Arkansas and worked as an assistant professor at Mississippi State University before coming to Texas in 2012. She's the liaison between Texas A&M Life AgriLife Extension and TNLA and serves on TNLA Education Committee and Park and Patio Task Force. So Dr. Gu is currently leading a multidisciplinary, multi-state effort to manage Crape Myrtle bot scale, and she's also interested in sustainable practices in horticulture production and landscapes, such as container substrate research. She offers Chat with Green Aggies webinar at noon every Thursday and a 3-day landscape short course in December. So, Dr. Gu, the floor is yours.
Thank you, Joseph, for the introduction. So do you all see my slide and just the slide itself?
Yes, sure do.
Okay. All right. Texas A&M AgriLife, it's very similar to the College of Ag where you guys are. And I think so many years ago, we adapted the name. So the whole division of Ag is called AgriLife. And I'm part of AgriLife Extension. And then we have AgriLife Research and the College of Ag. I really appreciate the invitation to talk to you all about getting the best on this, getting the best of pests. I wish I could be talking about a primary work scale, but I'm just as happy to talk about abiotic stresses on ornamental plants in the landscapes. I think this is a very important. This is a very important topic. The abiotic stresses, it's everywhere. Abiotic stresses, it's everywhere. When I did my PhD, my dissertation was drought stress of ornamental trees. It was very interesting. I learned a lot from that process. So the abiotic stresses, what I put at the bottom here, so these pathogens, virus, nematodes, bacteria, phytoplasma, etc., leaf miners, spores, beetles, whiteflies, scales, these are living things. Whenever stress, the problem that caused by them, we call them biotic stresses. Biotic stresses are caused by these living things. But what the environment is doing, we call these abiotic stresses. So biotic stresses, sometimes it's also called environmental stresses. And for plants in the landscapes, there are 5 main abiotic stressors. It could be temperature, sunlight, soil, water, and air movement. If you look at this picture here, wouldn't be nice? It would be nice if we have these iron plants that just not susceptible, quote unquote, not susceptible to any of these stresses. But of course, we are dealing with live plants most of the time that we are dealing with live plants. And for any live plants, they are subjected to one or more of these stresses once we put them in the ground. What they are, They are subjected to these stresses when they're in containers, when they are in production. But when they're in production, often we may be able to offer certain protection. But once they're in the ground, once they're in landscape, it seems like they're on their own. What I show here is not the USDA cold hardiness zone map, but this is rather a temperature. This is the American Horticultural Society plant heat zone map. This map is rather less often mentioned compared to the USDA cold hardiness zone map, and there's a reason for that. This map, if y'all could put in the question, I know it's a question. I'm really asking the question, but you could put in the Q&A. My question to you: what do they have in common? What do you think these two things have in common? These two things. It's a tricky question. It's really a tricky question. I hope I could hear some type in and stuff that let's see what you come up with. What do they have in common? So on the left is a lilac. On the left is a lilac. On the right is a vitex. Lilac and vitex. Lilac, the botanical name is syringa. So here's the thing. So often, most of us are familiar with lilac, syringa lilac on the left here, and this is we call this in Texas. We call this Texas lilac. We call vitex Texas lilac. So so these two things have in common is that they have both lilac in their common name. But I don't know about Georgia, but here, this is the reason, the reason we call this Texas lilac is because we can't have this lilac. I mean, if we could have this lilac, we don't necessarily have to have this Texas lilac. Might as well just call it the chase tree. But we like lilac so much, we call this Vitex lilac. And the heat zone map that I showed before, that's the limiting factor for us here in Texas that we can't have lilac. It's just simply too hot. This is a lilac is a zone 3 to 8, but they're really struggling in zone 8. And the heat is causing the struggle. And most of you are familiar with this limiting factor, this USDA zone map. It's based on the average annual extreme minimum temperature in the last 25 years on record. So what's the difference between these two temperatures? This USDA cold hardiness zone map, if you're saying it is grown in the area, let's say you're in zone 8 and you're growing zone 9 plants, it's sometimes in many years it's an instant kill that for sure. It's you have a cold winter and you're growing a subtropical tropical plant. It's basically an instant kill for you. Everyone is smart enough not to buy that winter killed plant again, to plant those winter killed plant again in the landscape. It's very different for the heat zone map. Sometimes we're like, let me just push in it. So what the plants are doing, that they're not necessarily going to die. They're not going to be instantly killed by the winter extreme low temperature. They're suffering. They're suffering. Just imagine a dog in a hot summer day, the dog extended their tongue and doing that panting. That's what plants are doing. That's what lilac would do in Texas and possibly in Georgia too. And talk about The cold temperature, gosh, don't we have something right here for you? Winter storm Uri that just happened in the middle of February. We had those just almost record low temperatures. Compared, this is the 2021 that we had. Very low temperature, and it depending on where you were, you guys were spelled. I suspect it's the winter, the moisture, the from the ocean that's protecting Georgia from this. But this winter storm, really, this winter storm Uri really gave us a very good opportunity to look at what are cold hardy here in Texas. We know that live oaks. We know live oaks are native right here in Texas, and live oak is actually native from Texas all the way to Georgia, South Carolina, North Carolina, all the area. And do you think that natives may be able to escape? Maybe just because they're natives, that they may escape this type of extreme low temperature? Not necessarily. And also because most times oaks are seed propagated. So each oak is genetically different from the other oaks. And so what we have seen is that in landscapes, there's a huge variation. There's a huge variation of cold damage on these live oak trees. So this is still during the winter storm, you still see the snow on the ground. Some pretty much defoliate 100%, and some retain its leaf almost 100%. And then this is just in case. So just take a mental picture of these leaves. Take a mental picture of these leaves. And this is what may happen, what cold damage to the leaves. Or I think in this case, it was actually freezing damage. It was freezing damage. The plants just basically just gradually lost its color. They sometimes they don't completely, like evergreen trees like live oak, they don't completely shed leaves like deciduous trees. But winter is when they get as close to deciduous trees on shedding old leaves. And this winter storm definitely accelerated shedding old leaves and stimulated the new leaf growth or not. And we have seen some of the live oak trees are still suffering from the winter cold damage. But again, it's just interesting. Take a mental picture of what freezing damage may do to an evergreen broadleaf plant. One of the things interesting about this winter damage is that just Joseph introduced, that we do a weekly webinar. It's called Chat with Green Aggies. And just almost right before this winter storm, we had a pruning. We had a tree pruning webinar. And on that, during that webinar, we mentioned some of the reasons for pruning, remove dead woods, removed disease wood, eliminate structure problem and stuff like that, eliminate hazards. And this is what happened. From this winter storm, that you can see that this is a very popular southern plant. It's wax myrtle. Because of the rain, the freezing rain, and then the ice accumulate on the branches. And this is what we have seen after this freezing event. So for plants with weak structures, and by the way, wax myrtles definitely has a very weak structure. If you think graph or pears, when they grow to a certain age, that they have weak structures, let me tell you, I have never seen so many floppy plants, and most of them are wax myrtles, just doing this after the winter storm. A lot of our plants here in Texas are very similar to what you all use in Georgia. And actually, I just came back from Georgia about a month ago. So let's look at some of the other plants that may be subjected to this extreme cold. We had several after this winter storm and after this 5 months of recovery. And these are some of we call it the biggest losers in landscapes. Most of the dwarf oleanders are pretty much gone. The bottle brush are pretty much gone. And then the Indian hawthorns are pretty much gone. But by the way, the interesting thing about Indian hawthorns, so for dwarf oleander, it's like completely gone. Bottle brush is completely gone. The Indian hawthorn, because they have this meatball, I call these quote unquote meatball shape. They're just naturally landscape meatballs. If you talk about the doing kitchen garden, let's put some meatballs here. So basically everything on the top are gone. And then you just see one flat layer of green leaves. It's probably gonna take it maybe 1 or 2 years or even 3 or 4 years to come back to the original meatball shape. So most of the landscapers or homeowners choose to just cut it off. And then why do we even grow all these tender tropical things? I explained to some of my friends, they're like, oh, all these palms are just damaged so bad. There's the reason, because although we always want to grow something that we can't grow, and we always want that tropical look, we want the beach look. So palm next to the swimming pool, that's a very common scene here in Texas. So all these palms, like aloes, and they are huge damage. These aloes basically just turn mushy. Bananas just mushy. The fan palms, a lot of the fan palms are. I'm going to show another picture. So what this one, the homeowner did, was very innovative. I don't know how effective it was. So he put Christmas lights. Wrap the Christmas lights, a growing tip here. I don't know whether that's effective or simply because the damage wasn't too bad. So this one actually survived, but the Carolina laurel cherry did not survive. And this is what I'm talking about, the tropical look that we often want to have, although we're slightly tender, this temperature. And actually, after 4 or 5 months, this fan palm, this phoenix palm, look, it's coming out green, and this Washingtonia palm, which is not very cold hardy, but fortunately, it's coming back. So it's not 100%. It's sometimes you may miss it, and you may have a good chance. And this type of blonde, I call it blonde. There's a better picture here. The blonde sago palm is not really a palm. It's common name, we call it sago palm. They all turn from green to blonde. And a lot of the sago palms are also propagated using seeds. And as you can see in this landscape, that the recovery, there are 3 totally different, distinctive recovery process for these sago palms, and this one never recovered. We are actually still collecting data, see what has recovered. It will be interesting to see all the things and what kind of damage that the plants had. During the winter storm, 1 month, 2 months, and 3 months after, and people keep asking us what to do when there is such a extreme cold temperature. So this is a very simple twig scratch test that can be useful. So on the left, we can see that the underlying tissue is brown, suggesting it's dead. And versus on the right, the underlying tissue is green. And so we know, so this is a simple test. This is a simple test showing it's dead or alive. But of course, for palms, for some of the tropical looking ones, when they don't have stems like this, it's hard to tell. And the only thing that you could do really, and that's what we recommended for folks, is just wait. Okay, so that was temperature. Temperature is something, like I said, it's for instance, the low temperature is almost an instant kill many times. So you wouldn't make that mistake again. You wouldn't plant that specific plants. And then for sunlight, for soil, for water, for air quality, for these type of stressors, they don't necessarily kill your plants instantly, but they may affect the plant growth. They may affect the plant health if it's not the right level that they wanted. And that slow decline in health may eventually cause plants to be prone to diseases, sex, other chronic stresses. It eventually led to death, and that's possible. So to talk about this kind of effect of these stressors on plant health, and we really need to look at two plant physiology basics, the photosynthesis and the respiration. So this is the process of photosynthesis. And the bottom one is the aerobic respiration. This is the aerobic aspiration. So you look at the two equation, it seems just so this is from CO2, water plus energy. The energy, that's the sun provides the energy coming in and make carbohydrates and give off oxygen. And the aerobic respiration is using that carbohydrates from photosynthesis with the help of oxygen. It releases energy, and that energy is used in anything. Just think about all the flower and fruit and growth. They all take energy. They combat in diseases, combating fending off diseases. They all take energy. So that energy is used in all processes of plant growth and development. These two processes are both affected by temperature. So this is Celsius. The unit here is Celsius. So at certain level, it increases both net photosynthesis and cellular respiration increases. But when it gets too hot, they both decrease. The respiration could actually tolerate slightly higher temperature. So in Texas, plants don't perform as in other states because we have very high night temperature. Plants don't get to take a break during the nighttime. So that's another stressor. That's not necessarily true in many other states. So this shows the difference between the photosynthesis and respiration. I guess one thing that's different is that photosynthesis occur only in sunlight or when there's light, versus respiration, just like we breathe in, it occurs anytime in both dark or under sunlight. So these plants, for ornamental plants, for landscape plants, one thing that we are looking is that we always looking for something different. We always looking for something unusual. If we say, oh, this variegated ginger plant, these variegated herbaceous plants, ivies, they look good. They're also looking at these contorted leaves, less leaf areas. These are all different. So these are all considered as ornamentals, as what we maybe call pretty. But all these, they have one thing in common is that they have less photosynthetic areas. They have less photosynthetic areas. That means they have they have less photosynthesis compared to their solid green cousins in the same family. And because they have less areas, if you think about it, would they use more or use less light compared to their solid green cousins? They use less, right? They use less. This is a picture, and this is not necessarily true. This is truly a hypothesis. This is truly a hypothesis that I need to test out. If you remember photosynthesis, they form sugar, carbohydrates. And there's just one day at a plant sale that I saw these oleanders. And I looked at it, oh, they're all scales. And then when I look close, this is something that I saw is that seems like most of the scales are concentrating on the green part. I was thinking, is that because the green part is making more sugar than the less green part? Could that be the issue? And this is it's not even a fun fact. It's just a fun hypothesis. So light level, because of the photosynthesis that's affecting everything that plant growth and development, there could be light level related problems. Too much sun for some plants is not good. And then not enough sun for some plants is not good either. And of course, these are different groups of plants. These are totally different group of plants. So whatever the symptom might be, what it does is weakens the plants. It weakens the plants and may even cause plant death. I'm going to use crepe myrtle as an example. Crepe myrtle by the way, is my favorite plant. This is a whole alley of crepe myrtle in Dallas Arboretum. Beautiful. What do you all think about this plant, this crepe myrtle? Isn't it gorgeous? Isn't it gorgeous? And if your crepe myrtle is not growing to this standard, to this level of flowering power, there's something that you need to think about. For instance, this is a picture of 2 rows, row 1 and row 2, 2 rows of crepe myrtle. Which side do you think is having more flowering power? If without the left side, without the row 1, if you look at it, you say, hey, this is actually pretty good. It's not too bad. But if you compare to row 1, well, there's the potential there not being realized. And why is it not being realized? Let's take a look at another angle. So this is row 1 and this is row 2. It's very obvious that row 1 is having a lot more flowering power than row 2. And of course, often we don't think this is a problem, because why we're not saying this is a problem? Because we don't see diseases, we don't see insects, we don't see sooty moth or something. But if you just think about it, it's not realizing its full potential. So for me, as a horticulturist, that's a slight problem there. And the reason I'm going to go back to this slide is that because this crepe myrtle is a full sun plant. And the reason that this row of crepe myrtle not realizing its potential is because these trees, these big cypress trees, Montezuma cypress trees that are just blocking the sun, that's making it not realizing its potential. This is in the plaza next to the Houston Convention Center. If you look on this side, on the outer side. So this group of 5 bush is planted right at the edge of this huge live oak plant. So look at the outside where it receives more sun, there are a lot of flowers. If you look at the backside where it's shaded by this live oak, it's put in not nearly as many flowers as the sunny side. It's not necessarily dying, it's not necessarily insects or disease, but it's not living to its full potential. What do you grow this firebush for if it's not flowering? We have plenty of greens. So that was an example of not enough sun. Not necessarily that plants will die, but if you put it under too much shade, like use cream myrtle as an example again, too much shade, it may cause the plant just not flower at all. And there will be a chance like that. And this is an example. This is some examples of plants having too much sun. Having too much sun, it may cause scorch like this. Like this is hosta. We know that hosta is more a shade-loving plants. They have adapted through all these years. They adapted to the shade condition. They just simply don't take too much sun. And then Japanese maple. A lot of the Japanese maples will totally melt under the summer heat in Texas. And then when you put them under shade, they don't show you the vibrant color that you grow Japanese maple for. And then too much sun is also a problem. When you see this kind of, basically, if you look at it just like a sunburn, this is lime sizzler firebush under full sun condition. Why is this suffering? And sometimes you can't even water it enough to make it not get the sunburn. And the reason is we're going to go back to the photosynthesis. So I have more pretty pictures here. Often with these variegated or color leaves, that their photosynthesis, although it's compared to their solid green leaf cousins, they don't have nearly as many photosynthetic units as the solid green leaves. So with that, they can't take nearly as much sunlight level as the solid green leaf cousins. So what you do is that if you put them under full sun, they're going to give you that literally burned look. By the way, I love this group of plants. Recently has been a lot of development in the red bud world. And these are some of the color leaf, variegated leaf varieties. And especially, this is the newest, my favorite. It's called Flame Thrower. If you haven't seen it, definitely check it out. From the Dr. Danny Warner from North Carolina State. But there may be an exception, and this is sunshine ligustrum. And I don't know whether you have seen this, how it's doing in your full sun conditions. And I think the reason for this as an exception is probably because it's a ligustrum. It's basically a weed. It's so strong, it's basically a weed. So that sunshine, that this chartreuse color actually tempered its vigor, its aggressiveness a little bit. So here in Texas, even under full sun conditions, that these sunshine ligustrums are still just doing great. So when it comes to soil, I can't grow camellias, azaleas, gardenias, as you all can in Georgia. Where I am at, an hour west of Houston. We just don't have the low soil pH that these things love. I can't grow these things. And when it comes to soil, we understand, a lot of us understand the pH. The pH often affect the nutrients, and salinity could be another issue, and drainage in certain areas could be an issue too. In certain spots in the springtime, we often see like this golden, as quote unquote, golden oat plants. It just, because of the pH is too high, and that's causing nutrient deficiency and the chlorosis. Not really sustainably golden, but really it's a deficiency. And then this nutrient deficiency is not related to soil pH, but related to certain specific plants. You may have seen it, specifically nickel. It's a nickel deficiency on pecan and birch. Again, this is not necessarily affected by pH, but you may not see this mouse ear disease. It's not a disease. It's called mouse ear disease. It's really a symptom of nickel deficiency on birch and pecan. Okay, here's the situation of soil drainage. Again, this is not necessarily at every landscape, but this is something that we need to pay attention to. We all know that nutsedge loves bad drainage, but here the drainage from the downspouts, the water, and we've got a boatload of water this year. The rain, we're still showering every day. The drainage here is so bad that even this bad drainage loving nutsedge is suffering. And on the other hand, there could be soil compaction limiting plants' roots access to air, and that could be bad too. Remember, the other process, two processes that essential to plants. One is photosynthesis. The other one is a respiration, especially aerobic respiration. Aerobic, that's the air that plants need for them to convert carbohydrates to energy. This is a water quality issue here. This may happen when you use, I think most water in the Georgia area is good, but this may happen when you use reclaimed water that has high salinity issue. By the way, this is our Tamu garden director. What he's pointing out here is not water quality issue. This is a beaver stress. Just taking the tree out. So what I'm circling here, as you can see, that the plants seem to have a brown skirt, and the brown skirt is caused by sprinkling water. And our city water is salty. And the sprinkle water shoots on the leaves, and leaves often have lower tolerance to salt damage. And these Mononuma cypress, these oaks, these maples are just not tolerant of the salinity issues. So they're having this brown skirt. And one way to fix this problem is, I don't know where the sprinkler head is, instead of letting the sprinkler head spray too high, adjust the angle, let it spray to the trunk. Or another way would be limb up the trees so that it wouldn't affect those lower leaves. I think I'm going to go, I need to go a little bit faster. So there are ways the plants use water differently. For instance, Dusty Miller is very hairy. So what these hair do is that it retains water. So for plants like Dusty Miller with this much hair, and also because of the color, the silvery color, it reflects off a lot of sun. For Dusty Miller, I have seen in landscapes that it just drowned. It's just too much water, drowned to death. It's a very drought tolerant plant. So compare these two magnolias, southern magnolia with very waxy leaves versus the sweet bay magnolia. It has papery leaf. If everything else is equal, which one do you think may use more water? The waxy leaves it's a layer preventing water from losing too fast. So this southern magnolia would be more drought tolerant than the sweet bay in most cases. And then if we compare the thick leaves versus the thin leaves of thick leaves on live oak versus the thin leaves of hosta, and also not only that, and compare the solid green leaves versus the variegated leaves. This one is going to have higher level of photosynthesis, and higher level of photosynthesis uses more water than this one. Sorry, I just noticed that I was pointing my mouse on a wrong screen. This is a Texas mountain laurel. By the way, we love mountain laurel. We can't have it, so we named this one Texas mountain laurel because we love mountain laurel. Got this beautiful flower. It's really in the legume family. It's very drought tolerant. What issue that we may see in the landscapes is drowning, especially in East Texas. Very waxy, thick leaf. This is a Texas sage or Synesium. It has very hairy leaves. It's whitish, very nice. It flowered last year. It flowers when there's plenty of moisture. It flowers when there's plenty of moisture, and then it goes to the dry spell, and then there's moisture again. It's gonna flower again. So in Texas, this thing, or in the dry area, I should say, that it will create several flush of flower shows, just like this, 5 to 6, maybe 7. But then if you put this under a too well-watered situation, what would it do? It does not have a fantastic show like this. What it would do is put on 1 or 2 flowers today, tomorrow, so it just drags on. I'm going to come back to the redbud that I showed some of the variegated leaves. And if you look at this one, let's not even talk in the California redbud or the Mexican Texas redbud, but just the eastern redbud, Cercis canadensis. It's native all the way from Mexico to North Carolina. Would you think that? And we know the condition of West Texas, New Mexico will be very different from Florida or North Carolina, just from the water standpoint. And plants collected. So there's a provenance difference. So plants collected and propagated in this area would definitely be different from plants collected in this area. Although they're all eastern redbuds, they're all the same species, but just because of provenance difference, they will behave differently. Just in a human being, let's say in a human being, comparable to a human being behavior, some people could tolerate a lot of heat. Some just can't take hot food at all. Oh, by the way, this is a very cute thing about redbuds. A lot of people may not know redbuds, but if you tell them, hey, these are hummingbird trees, because if you look at the hummingbird, if you look at these individual flowers, don't they look like a hummingbird? Transpiration, wind. No, I'm going to move fast. One of the things that I want to mention here is that transpiration is affected by relative humidity. Transpiration decreases with increase in relative humidity. It increases with increase in temperature, wind, or sunlight. So transpiration loses water. Plants loses water from transpiration. When there's too much wind, especially when there's too much dry wind, and then you may see scorch. You may see scorch, leaf marginal scorch, like this. And if you think about it, salinity or drought could be causing similar symptoms. This is when you need to evaluate, is this symptom caused by salinity? Is there a source for salinity? Is it caused by water? Not enough water? These are some of the situations that we could evaluate or that we need to evaluate. And this is actually not too bad when there's too much wind. And that's really bad. That's really bad when there's an extreme wind. And often the plant's roots are very limited in the urban environment. And so that the anchorage function of the roots are very severely limited by the pavement, just by their limited um, root growth area. So this could happen under just strong wind. This is very different from all the previous abiotic stress that I mentioned. This is human damage, really, herbicide damage. You look at these crepe myrtles. You look at all these crepe myrtles that they have. They are trying to come out. They're trying to come out with more, but actually it's very detrimental to the plants. And what you can't see on this one is that this breath or pear is showing similar symptoms. So when this kind of situation happens, how could something happen, similar symptoms happen on breath or pear and crepe myrtle, totally not related, not even in the same family? When this kind of thing happen, but they're happen geographically, location wise, they're very close. And this is when you need to think about all these abiotic, these environmental stresses. So I group this herbicide damage, this human caused damage into the same, although humans are living like a fungi, insects, but this is still similar to environmental stress just caused by human being. So really the take home message is that right plants for the right place. Whether the right plants is at the species level or cultivar level, the right place could be the cold tolerance and also the sun level, the sunlight, the light level, the drainage level, that kind of thing, plus a little bit TLC for the plants. So this is a little selfish, shameless promotion. We are working on crepe myrtle bark scale. We have a website called Stop CMBS, stopcmbs.com. And I would like you guys to go to the updates, because the reason that we often update our information from our research. And one thing important I want you all to know is that it does not only affect crepe myrtle. That's the scary part. It does not only affect crepe myrtle and affect so many other things. I won't spill the beans. I really hope that you could go check it out and see a whole table of plant materials that may be affected by crepe myrtle. And that's the end of my presentation. I really appreciate your patience. Thank you. Thank you.
Thank you so much. So this is the time for any questions you may have. Please do not hesitate to write it down at the Q&A, and so that Dr. Mengmeng can go over and answer those. So we have some time, not a lot of time. Please go ahead and write your question. So while people are writing their questions, thinking about that, so Dr. Gu, have you seen any where some insect problems? I'm sorry, I'm more biased towards insects. So insect problems and stress, any particular situations that you want to highlight, or any situation that related to temperature or any stress factor that you want to highlight?
So
I
you're
mean,
asking about insect.
insect issues and the stress that kind of pops out in your head.
Of course, we call these things stressors. Either that stressor being insect chewing, insect sucking, or being sprayed with herbicide, or being planted at the wrong place, so that it's not growing to its full potential health wise. It's definitely. I'll give you an example on Kramer bark scale. It's interesting that I went to a local university and okay, here in Texas, we love crepe myrtles. Crepe myrtles are grown everywhere. So there is a dorm building. So on all sides, the south side, the north side, the west side, the east side is not too many, but on all these sides, they were planted with crepe myrtles. And guess which side has more scale? The north side or the south side? Gene, I can't hear you. You can unmute yourself. What do you think of the south? You think the south is having more, the plants on the south are having more scale. Why? Why?
I just figure the stress on the plant, that there would be so much more water use, transpiration, sunlight, that kind of thing.
But you're not listening to my presentation. I just in my presentation I mentioned that crepe myrtle is a full sun plant. Shade is actually a stressor. So compared to full sun, shade is actually a stressor for crepe myrtles. So the plants on the north side are loaded with the scale. And of course, scale themselves also enjoy the shade versus the plants on the south side have considerably a lot fewer scale than the one on the north side. So the shade is a stressor for crepe myrtles here. And of course it's all different. That's why right plants for the right place.
Great, thank you. So it looks like we have a question. So many turf herbicides say avoid drip zone or exposed roots. What are safest turf herbicides around trees? How safe are the sulfuron type herbicides around trees?
Wow. And you all know that the symptom that I showed, it was a kind of 2,4-D type of, and the 2,4-D acts like auxin. So as a type of plant growth regulator, so it's stimulating plants, stimulating the crepe myrtles to, and in that case also brachypod pears to grow more shoots. And that's what happens. Any movement facilitating turf herbicide may cause that kind of damage. If you take away the first quote unquote facilitation, like certain dormant season when plants are not growing or are not actively taken up, that could be one. But then this roots, only thing I can say, I don't know which one is the safest turf herbicide. And then it just when you apply the herbicide, you just be extremely careful. Definitely extremely careful. I agree with avoid drip line, and that's definitely a good thing to do. Yeah.
That's great. So looks like we have one more question I will take before we move on to break. So the question is the best preventative practices for powdery mildew on crepe myrtles.
We have seen. I love crepe myrtles. I love powdery mildew. Doing some work on crepe myrtles, and when I touch there's one specific cultivar that's covered with powdery mildew, and when I work on it, you could just see it's fluffy, like snowflakes, fluffing off. That's just so bad. And I can't tell you because we're recorded, so you need to contact me in private. I'll tell you what code for that is. The best practice is prevent. Is is just not growing those because it's hard. It's going to come back year after year for you. If it's powdery mildew is bad, I would say just cut it off and plant new ones. And the thing is from the National Arboretum in the 70s and 80s, there has been so many cultivars developed by National Arboretum, specifically by crossing Lycostronia foriae with Lycostronia indica to create that powdery mildew resistance. So definitely make full use of all those nice cultivars.
Thank you so much, Dr. Gu, for the investigation. I think we all enjoyed.
Thank you for the opportunity. Thank you.
Yeah, thank you.